Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. Today we've got an update on a story we brought you yesterday, a second launch attempt for a massive communication satellite.
Fingers crossed for that one.
Celebrating an incredible milestone for a deep space explorer and witnessing a first in U.S.-China space cooperation, plus a stunning 3D map of a distant world from JWST and a look at Europe's ambitious launch plans.
It's a busy day in the cosmos. Let's get right to it, starting with that nail-biter down at Cape Canaveral. So United Launch Alliance was planning on giving it another go tonight with their Atlas V rocket.
That's right. They were hoping to launch the Viasat 3 F2 satellite. Liftoff had been scheduled from Cape Canaveral at 10:16 p.m. Eastern, right at the start of a 44-minute window.
However, the launch had to be scrubbed the second time this week. The first attempt last night was also scrubbed.
The valve issue that prevented a launch Wednesday night remained persistent on Thursday. Launch director James Whelan scrubbed the launch attempt Wednesday night when a vent valve on the Atlas V's first stage liquid oxygen tank failed to work properly during final pre-launch checkouts. Then again, a little more than an hour before the Thursday night window opened, ULA said it was foregoing the launch attempt with the same valve issue causing the problem.
A third attempt has already been touted, but no date or time just yet. So tell us about the passenger. This is a pretty significant satellite, isn't it?
It really is. The Viasat V3F2 is a hefty communication satellite, weighing in at 6 metric tons. Its job will be to provide K-band network capabilities, essentially high-speed internet, over the Americas.
And this is the second in a series, right? How did the first one fare?
That's the part that adds a little pressure. The first one, launched in 2023, unfortunately suffered an antenna deployment issue that significantly reduced its capacity. So there's a lot riding on this mission for Viasat.
Absolutely. Well, we'll be watching for news on the third attempt details.
From a new beginning, let's turn to an incredible, decades-long journey. We have a milestone coming up for one of humanity's greatest explorers.
Oh, you have to be talking about one of the Voyagers.
Exactly. In November of 2026, Voyager 1 will become the first human-made object to travel a full light day away from Earth.
A light day. That is just staggering to think about. That's about 25.9 billion kilometers.
It is. Remember, this spacecraft was launched way back in 1977. It's already in interstellar space, having left the sun's direct influence behind. Now it's heading towards the Oort Cloud.
The Oort Cloud, the great icy shell at the very edge of our solar system. And it's still talking to us after all this time. It's hard to fathom, how is it even powered after all these decades?
That's the one. And the timescales are mind-boggling. It will take Voyager about 300 years just to reach the inner edge of the Oort Cloud.
Wow.
And another 30,000 years to pass completely through it. The journey is almost eternal. And what happens after that? In about 40,000 years, it'll make a relatively close pass of another star, Gliese 445. It will actually be closer to that star than it is to our own sun.
And all that time, it's carrying its message in the bottle, the golden record.
That's right. A message from humanity, just in case any extraterrestrial intelligence ever finds it. It's a testament to our curiosity and our hope to connect with the cosmos, a truly profound legacy.
An incredible mission. It really puts our own sense of time into perspective. Well, from reaching out to the unknown, let's talk about connecting a little closer to home. There's been a really interesting development in orbit between the U.S. and China.
This is a significant first. For the first time, the China National Space Administration proactively reached out to NASA to coordinate a satellite maneuver.
Right, to avoid a potential collision. So what's the big deal here? How did this work before?
Well, previously, NASA's orbital tracking would identify a potential conjunction and they would notify China. It was then typically NASA or the US Space Force that would perform any necessary avoidance maneuvers.
So this is a reversal. China reached out first and handled the coordination. What does that tell us?
It suggests that China's own space situational awareness capabilities have improved dramatically. They are now able to track, predict, and act on these threats with high confidence.
That's crucial, especially now. The number of satellites up there is just exploding.
Exactly. We have mega constellations like SpaceX's Starlink and China's own Guoang network being deployed. Low Earth orbit is getting very crowded very fast.
So, more communication and coordination is essential to prevent disaster.
Absolutely. This move is a really positive step for the safety and sustainability of space operations for everyone. Speaking of seeing things more clearly, let's jump from low Earth orbit to a world hundreds of light years away. The James Webb Space Telescope has given us another incredible first.
JWST is the gift that keeps on giving. What has it found now?
Astronomers have used it to create the very first three-dimensional map of an exoplanet's atmosphere.
A 3D map of the air on another planet? That sounds like science fiction. Which planet did they look at?
The target was a fascinating one called WASP-18b. It's what's known as an ultra-hot Jupiter. It orbits its star so closely that its atmosphere reaches temperatures hot enough to destroy water vapor.
Wow. Okay, so how do you even begin to map something like that?
They used a brilliant technique called spectroscopic eclipse mapping. As the planet passes behind its star, JWST carefully measures the changes in light. By analyzing this data, they can build a picture of the temperature at different altitudes and locations.
A temperature profile in 3 dimensions. What did it show?
It revealed some really significant temperature variations across the planet's atmosphere, giving us insights into its weather and energy circulation. It's far more complex than our previous 2D models suggested.
That's amazing. And I assume this technique isn't just for hot Jupiters.
That's the most exciting part. This new method opens the door to studying the atmospheres of many other exoplanets in much more detail, including potentially smaller rocky worlds like our own.
Incredible. From 3D maps to launch manifestos, our final story today takes us back to Earth, focusing on Europe's ambitions in the launch industry. Arianespace is looking to seriously ramp things up.
They certainly are. The company is aiming to double its Ariane 6 launch cadence in the year 2026.
Double it? The Ariane 6 is still relatively new, having debuted in 2024. How many flights are we talking about?
Well, after flying 3 times in 2025, the plan for 2026 is to conduct between 6 and 8 missions. It's a very ambitious schedule.
What's enabling this increase in pace?
They're getting more efficient with launch processing, but more importantly, they're introducing an upgraded Block 2 version of the rocket in 2026, which will boost its performance.
More power, more launches. Do we know what they'll be launching?
We do. The very first launch of 2026 will be the more powerful Ariane 6-4 variant. Its primary payload will be a batch of satellites for Amazon's Project Kuiper constellation.
Another mega constellation driving the market. So, what's the long-term goal for Arianespace?
Ultimately, they're aiming for a maximum launch cadence of 9 to 10 flights per year, driven entirely by customer demand. It's a clear sign that the global launch market is hotter than ever.
And that's a wrap on the big stories from around the cosmos today. From another launch scrubbed at the Cape and Voyager's lonely journey to new cooperation in orbit, 3D alien atmospheres, and the bustling European launch pad.
It's a reminder that there is always something new to discover, both near and far. Thank you so much for joining us.
Be sure to subscribe to Astronomy Daily wherever you get your podcasts so you don't miss an episode. Until next time, keep looking up.